Hello students, welcome back to our class. In the previous session we discussed what is the definition of arithmetic progression, and now we are going to discuss what is the general form of an arithmetic progression, right? See, first suppose when you have any arithmetic progression, like depending on the property that we discussed in the previous class, every sequence in which each term is obtained by adding a fixed number to its preceding number. Any sequence in which each term is obtained by adding a fixed number to its preceding number, except the first number, is said to be an arithmetic progression. So, in any arithmetic progression, let me take one arithmetic progression like 2, 5, 8 and then 11 and so on. So, this is one arithmetic progression. How can I say that this is an arithmetic progression? Because here the first number is 2 and the second number is 5 and third number is 8, fourth number 11 and so on. So, each term is obtained by adding 3 to its preceding number. So, that is why we can say that this is an arithmetic progression. So, in any arithmetic progression, the very first number is indicated by small a and you can call it as first term. So, a is equal to first term of arithmetic progression, first term of arithmetic progression, right? And see what is the term that you are adding to every single term. See, when you observe, first term is indicated by a, generally first term is a1 is equal to 2, that is the indication of a. And what is the fixed number that we are adding here? The fixed number is 2 plus 3 is equal to 5, 5 plus 3 is equal to 8, 8 plus 3 is equal to 11. So, that the fixed number that we are adding is called common difference. Why do you call it as a common difference? Because that is the difference between second number and first number, third number and second number, fourth number and third number and so on. So, that we can call it as a2 minus a1, a2 minus a1 is equal to 5 minus 2 is going to be 3. And what is a3 minus a2? a3 means third number minus second number, third number is 8 minus second number is 5 is going to be 3. And suppose if you want, you can check a4 minus a3 means fourth number minus third number also. Here the fourth number is 11 minus 8 is going to be 3. See, in every single case 3 is common. So, that 3 is the difference which is common for any two consecutive terms. So, that is why that 3 is said to be common difference. So, what do you call that? That is said to be common difference. So, here common difference is indicated by the letter D, like how you indicate the first term by A, we indicate common difference by D. And how do you check the common difference? Just by using these things. They are common difference is equal to a2 minus a1 which is equal to a3 minus a2 which is equal to a4 minus a3 which is also equal to, we can give one general formula for common difference. See, second term minus first term, third minus second, fourth minus third. Suppose if I know what is nth number, then I can say that nth number minus n minus 1th number is the formula for common difference. In fact, if you want to check whether the given sequence is an arithmetic progression or not, this is useful to figure out whether the sequence is an arithmetic progression or not. Hope you understand. If you find a2 minus a1 and a3 minus a2 both are same, then it is an arithmetic progression, otherwise it is not an arithmetic progression. Hope you understand. So, these two things are very important in arithmetic progression, that what is the first term. So, what is the indication of the first term? Indication of the first term is small a. And what is the indication of the common difference? Common difference is equal to D. So, that D is a2 minus a1 or a3 minus a2 or an minus 1. So, with the help of this a and D, let us try to form what is the general form of arithmetic progression. What is the general sequence of an arithmetic progression, where a is the first term and D is the common difference, right. So, now we are going to discuss about what is the general form of arithmetic progression. So, let me take one arithmetic progression. Fine, I am going to take 1, 3, 5, 7, 9 and so on. This is clearly an arithmetic progression because a2 minus a1 equal to 2, a3 minus a2 is equal to 2. So that I am clear here that a2 minus a1 is equal to 2 and a3 minus a2 is also equal to 2, that 2 is the common difference, right. And what is the first term here? And the first term is going to be a is equal to 1. Okay, let me write in the form of a general sequence of an arithmetic progression with a as well as d. Okay, what is the very first term here? The very first term is a1. a1 is equal to 1, right. So what is the indication of that 1? That is a. And the second term, what is second term here? Second term is 3. I am going to write that second term with the combination of a, that is 1 plus 2 is equal to 3. So instead of this 1 I would write a, and instead of this 2 I am going to write common difference. Okay, and coming to third term, that is a3 is equal to 5. I am going to write this 5 with the combination of a and d again. So a is equal to 1 plus 5 is equal 1 plus 4 is equal to 5, writing that 4 as 2 times 2. Can I write like that? Yes. Instead of this 1 I will write a, instead of this bracket 2 I will write d, so it is going to be 2d. And coming to the next number, a4, what is the fourth term here? Fourth term is going to be 7. So 7 that I am writing here it as 1 plus 2 into 3. Here this 1 is a and 2 into 3 is going to be, this is 2 3s are 6, no, 3 2s are 6, but we are missing the sequence, the pattern that we are missing. So that I would write here within the bracket 2, outside the bracket it is 3. So then it would be 1 plus 3 into 2, that is a plus 3 into 2. So 3 into 2 is d only, right. And coming to the next number, that is fifth term of the sequence, the fifth term is going to be 9. So 9 is equal to 1 plus 4 into 2, which is equal to a plus 4 into d, and so on. Once you observe here, the first term is going to be a1 is equal to a, second term is going to be a plus 1d, third term is a plus 2d, fourth term is a plus 3d, fifth term is a plus 4d, and so on. See here it is a plus d is nothing but 1d, and here there is no d. Can I write it as 0 into d? Correct. If you once observe closely, fifth term is 4d, fourth term is 3d, third term is 2d, second term is 1d, first term is 0d. It means whatever the suffix here, then the coefficient of d should be 1 less than the suffix. Whatever the number you take, see here suffix is equal to 4, coefficient of d is 1 less than the suffix. So I would write this in terms of the suffix, that is a plus 4 can be written as 5 minus 1 into d, and here a plus 3d as a plus 4 minus 1 into d, suffix minus 1 into d. Here a plus 2d as suffix plus 3 minus 1 into d, and here also a plus suffix minus 1 into d, and here also a plus, what is that suffix here? 1. So 1 minus 1 into d. Now you see clearly you can form one nth term of arithmetic progression. What is the nth term of arithmetic progression? For suppose a n would be the nth term of arithmetic progression, that is going to be a plus suffix minus 1 into d. This is what you call as nth term of arithmetic progression. And what is the general form of arithmetic progression? First term is a, second term is a plus 1d, third term is a plus 2d, fourth term is a plus 3d, a plus 4d, and so on, a plus n minus 1 into d, right. So with the help of this we can easily form an arithmetic progression where a is the first term as well as d is the common difference. So I am going to write now what is the general form of an arithmetic progression. So general form of an arithmetic progression. So general form of an arithmetic progression is going to be the first term. What is the first term here? first term is going to be a1 which is equal to a, second term is going to be a2 is a plus 1d, and the third term is going to be a3 which is equal to a plus 2d, and so on. Nth term is going to be an is equal to a plus n minus 1 into d, right. So, now I am going to write the general form of sequence arithmetic progression with the help of this information, that first term is a, second term is a plus 1d, third term is a plus 2d, fourth term is a plus 3d, and so on. What is nth term? A plus n minus 1 into d. So, what is the use of this nth term of an arithmetic progression and general form of an arithmetic progression? Let us discuss about that. In this is what called general form of an arithmetic progression, especially this a plus n minus 1 into d is called general term or nth term of an arithmetic progression. Did you understand? General term, otherwise nth term. General term or nth term of an arithmetic progression is a suffix n is the indication of nth term of an arithmetic progression, which is going to be a plus n minus 1 times d. This is what called general term or nth term of an arithmetic progression. So, hope you understand what is the indication for the first term, second term, third term, fourth term, and so on, nth term, where common difference d can be calculated by taking a2 minus a1 or a3 minus a2. So, let us have a few set of examples on this nth term of arithmetic progression. Okay, first suppose you are given an arithmetic progression, that arithmetic progression in 3, 7, 11 and so on, 3, 7, 11 and so on. What is 25th term? In this sequence, what is 25th term? See, basically this sequence is an arithmetic progression or not? Obviously, this is an arithmetic progression because 3 plus 4 is equal to 7, 7 plus 4 is equal to 11. So, that this forms an arithmetic progression. So, in this arithmetic progression, you will have to write what is the first term. So, first term is a1, that is going to be a, which is 3 is the first term. And what is common difference? Common difference d is equal to a2 minus a1, which is equal to 7 minus 3, which is equal to 4. That is the common difference. And then you are going to find what is 25th term. So, 25th term of AP. What is the formula for 25th term of AP? That is A25. What is the formula for A25? A plus suffix minus 1 into D, that is nothing but A plus 24 times D, correct. The value of A is going to be 3 plus 24 times D is going to be 4. So, that is 3 plus 24 4s are 96, 96 plus 3 is equal to 99. This is what is 25th term of this arithmetic progression. So, this way we can easily find what is 25th term of arithmetic progression and what is the required term of arithmetic progression. So, that is what is about the use of nth term of arithmetic progression. So, hope you understand how to use this nth term. Thank you.